different approaches to managing systems. For those who saw Ansible by DAC, I will be covering the overview of the different tools, not the in-depth tool itself. So yeah, first, who am I? I'm Toshan Barvani. I'm from Antwerp, Belgium, also self-employed. I'm involved mainly with enterprise Linux. I like to keep things secure, so last year and most of my previous years it was about SE Linux. Yeah, I want to take over the world, but I think everybody wants to do that. So I have some hardware and some software things, so that's why system management is one of them. So the first is the introduction, basic stuff, then some configuration management tools, and then some configuration and execution management tools. So yeah, in the old days you could go to a single machine and have physical access. So you would log on through the keyboard and use your screen. I doubt many people still use that method today. The most used might be still a serial console for embedded devices, but that's a specific use case then. You have single remote machine management, which is SSH. For those people in the Windows world, you might start using PowerShell. For some networking devices, that might be still Telnet. I don't know if you want to use that over the internet. Central package management has also been something around for a while, is RPM, Deb, eBuilds. So what some companies have been doing is putting your configuration of your system into an RPM package or into a Debian package. Emo24.de is doing that, for instance, so they're using RPM packages to distribute their configuration management. Yes? It's off? Okay.
I think the battery is out. Do we have spares?
But is it necessary? Or can I just talk a little bit louder? Okay, so Emo24, for instance, uses RPMs to distribute configuration management. Many other companies have been doing that in the past. It's not an optimal way. It also requires you to wait for a certain interval till you get your updates, so it cannot be pushed instantly. Of course, we had other remote execution systems like cluster SSH, parallel SSH, and some other newer tools. Then you had the configuration management tools, which basically have your configuration in a database in flat files stored on a master, and from there you distribute it to the other machines. Most used and most known is Puppet, but there's also Chef, CF Engine, BCFG2, and then the newer ones, which are configuration and execution management. So most of them grew from an execution management perspective and added then configuration management in there. Configuration management is the general idea that you want to, for instance, configure your web servers with a specific configuration, or you want to configure your database management server with a specific database configuration. One of the oldest ones I found was CF Engine. Well, first, before I start the overview, I'm only going to talk about open source tools. So HP, IBM, most of the hardware manufacturers have their own proprietary tools. I won't be talking about those. In specific cases, you might need those, but in general cases, these will do. So CF Engine started as a research project, was then made into a software, was written in C. It requires a server and a client. So that means you need a server, a daemon running on a master, and a client, an agent running on your server that you want to be managed. It's a framework, so it requires you to do a lot of extra work on it. It doesn't work out of the box. In most cases, you will need to set up a full environment, and it can take you some time and experience before you get that. It uses what it calls cookbooks. The main problem with cookbooks is it allows you to do anything in there. So you can write it in any language you want, you can write it in any way you want, you can generate it any way you want, which is also good in a perspective, but it allows too many options, and therefore you need to define those options also in the system. It works on Linux, Unix, and Windows. So when I mention Unix here, I'm talking about all variants of Unix, proprietary and open source. Then you had BCFG2. It's Python based. It also requires a server and a client, so a daemon and an agent. It uses a direct abstraction layer, so it defines everything in XML files and uses those XML files to execute, to distribute the configuration. It only works on Linux and Unix. Even though Python runs on Windows, it's not supported because it cannot configure the necessary services in those systems because of the agent having to run on the client. I've only heard it being used in specific grid cases where all your machines are the same layout. It's not that popular or known. Then Spacewalk initially started as more as a license entitlement management system, grew then to do provisioning and configuration management. It's based on Java, Perl, and Python. It has a database running behind it. It's developed by Red Hat. It has a server where you need to have the full software stacks with a database, so PostgreSQL. It's a specific platform integration, so it requires you to have on the server side a Red Hat-based environment and can manage only Red Hat, SUSE, or Debian-based machines. So it's very specific. If you use only those particular distributions in those particular ways, that might be a good solution. Juju, which is the counterpart from Ubuntu. It's Python-based, and newer releases are Python and Go-based. It also requires a database. You actually have in the newer releases the option to use Postgres and MySQL. It also requires server client. It's again a specific platform, so it only targets Ubuntu, even though Debian is supported, but as it's pushed by Ubuntu, it's more Ubuntu based. There are a few cases where I've heard people using it, but then you have to have a full install of Ubuntu, of course. Then the most known one, Puppet. It's Ruby based. It runs as a server client, so it requires you to have an agent running on your machine you want to manage. The master can be anything basically. It keeps the configuration files in flat files. Recommended is to use a version management system. Nowadays that will be mostly Git. It's a high abstraction layer, so it still requires a quite steep learning curve. Once you get used to it, most people who do use it are very happy with it. They won't see a big use case into changing into newer type of configuration and execution management systems. It works on everything, so Linux, Unix, and Windows. it uses manifests, so everything is written or in Ruby itself or in a specific DSL. There are quite a lot of manifests out there, so it does currently cover most, if not all, of the standard services and configuration possibilities. Chef, and if you notice well, there is only one word different between, well, two words different between the slides. That's because Chef is a fork from Puppet. It uses cookbooks in place of manifests. Initially, it used only specific DSL, which in later versions have been made more generic. So it's a more Puppet based language, and it has the Ruby DSL. So you can interchange cookbooks and manifests. It's not 100% compatible in all cases, but in some cases it is compatible. And again, it works on all systems. The main difference is Chef presumes that you're going to use a cloud-based system. So it pushes you more towards cloud-based computing in place of your own base. So if you want to use it in-house, setting it up is quite a lot of work. It requires you to have a dependency list which is quite long. I mean, I wouldn't be able to mention that on a slide even. The newer ones, one of the older ones I found was Staff. Staff is software testing automation framework. It was invented by IBM, and it therefore targets all IBM-based systems under rich Linux. It is open source. However, it is C++ and Java based and requires you to execute commands from an Eclipse client. So it's not necessarily a lightweight thing that you can just run anywhere. It also uses XML files as configuration. For those that like XML files, this might be useful. In most cases, XML files are larger than most normal configuration files. Salt is actually a Fedora project, which came further from the fact that Spacewalk was more focused towards the enterprise Linux, whereby you had entitlements. Salt tried to target the more common approach of managing systems. It was written in Python because that's the standard, or that used to be the standard language for Fedora. It requires you to have a server and a client, so it defines what it calls Salt masters or Salt syndicates, and then to have Salt minions, which are the agents basically. And it communicates using SSH or 0MQ. The 0MQ is used for fast access. So the idea of a syndicate is that you can run a syndicate within a secure environment using SSH to connect between your master and your syndicate, and then use the syndicate to communicate using 0MQ with your minions. Configuration management was a feature that was added afterwards. You see that because they don't have a specific definition on how configuration should be done. So it allows you to use JSON, YAML, Jinga, Mako, Wempi, pure Python, if you prefer that. So it gives you a lot of options, and it doesn't define from the software stack exactly what needs to be done. So this is an overview of it. You have a master where you have your configurations on. You can then contact or directly minions, which are agents, or your servers, physical or virtual. You can then connect or to a syndicate, which connects to its minions, and you can of course have a syndicate of a syndicate. So it allows you to jump over hosts and to go into secure zones, which is nice if you have DMZs and internal, or you have to go through a physical machine to get to your virtual machines. But in the configuration management perspective, it is quite rudimentary and quite simple. Well, not simple. It's quite not well defined on what is or could or should be done. It's more like you can do this and you can do that. Then the last one is Ansible. For those who saw Doug's presentation, it's much more in depth. So it's Python based, it's server based. You don't need an agent on the client side. You don't even need Python on the client side. It uses SSH. It can use ZeroMQ, or it can even connect directly to Git. It uses something it calls playbooks. Playbooks are basically YAML, or YAML which get converted to JSON. So you can write scripts also in, or you can write configuration also in JSON, which then gets converted to YAML, which then gets used into a playbook. And it works on the server side on any system where you can run Python, basically. So Windows is also supported there for those who have Windows desktops at work. So that was my overview. My idea was actually to have a more discussion about what these tools can and cannot do. So if there are any questions or specific things you would like to see or ask. Yes?
Why didn't you include with Puppet Marionette Collective?
Why did I not include M Collective is the question. M Collective is not a standard tool in Puppet, so you can use different tools also to get that information. There have been use cases where OHI has been used to collect information. So M Collective does not solve the complete stack and is not, if I remember well, supported by Puppet out of the box. So you are required to do some extra steps for that.
Yes, you need to install it, but beside the fact gathering, it gives you the capability of having an MQ and doing things basically with the agents which listen to the queue. So for example, you could trigger remotely a service restart on several nodes based on different conditions.
Yeah.
And that adds a lot of flexibility and capability to Puppet, because basically then you can program and react to whatever you need.
Yes, but again, it's an external component. It's not standard into the Puppet tool as a Puppet tool. You could connect OHI for that and do it. You could connect Nagios and do that. So you can script that in any way you want, but it doesn't work out of the box by default normally. So my point was to go over the list of things that it can do out of the box, which is not always the way that people work. So M Collective is a feature that can be added to Puppet, but also to Chef, for instance. So it might be a tool I need to add as a separate thing within the stack, yeah. Yes?
At the company I work at, we have a couple of virtual hosts, and we're migrating, or we're working on using, does some stuff the first time to install some packages the first time. But what do you recommend? What are the easiest ways to get going, or?
So if you have to start today, and your time of investment is small, use something like Ansible or Salt, because those are tools which you can set up quite easily. Ansible, I got it running in about 5 minutes. Dag claims he can get it running in 10 minutes. If you see, it varies what you want to do obviously with it, but it's anywhere between 5 to 10 minutes, 15 minutes, and you can have a system up and running. If you want to start something in Puppet, if your install base is of course much larger, then that might be a way to go. At this point, Ansible will most probably still change some things internally, whereby Puppet has become more stable than a year ago. Another aspect you have to think about is, are you running normal machines? Are you running embedded machines? Do you want to cover the full stack? So where Ruby doesn't run, you can't use Puppet. As it is, as Ansible allows you to have external modules in any language possible, it is again favorable if you want to use those type of things to use Ansible. Yes?
Do any of these tools, for example Ansible, also deploy?
Deploy what exactly?
Well, do an installation for you, or is it?
So you mean provisioning of machines and everything? Yeah, they all do that. So in all cases, except Staff, I think, most of them, so Puppet, Chef, Salt. No, Salt cannot do that without an external component. So Ansible, those three can do that by default. So you can provision machines, you can provision virtual machines, physical machines, anything you can access. So if you have, for instance, third-party firmwares which can talk to you using SSH, Telnet, or any other connectivity, you can talk to them like that. Yeah.
Another question. These are all tools that see the different machines as individual boxes. Are you aware of any efforts that look at a collection of machines as one system?
If you mean grouping systems,
Like the Plan 9 approach, where you install an operating system on a network of machines instead of.
I'm not fully aware of what you mean by Plan 9 and a network install, but if you mean that, let's say, grouping machines together and executing on a group, yes, all of them can do that. That's not a problem. Can you run machines from a network OS? Yes, if you define it like that. Any other questions, discussions?
Then I would like to thank the speaker.
Well, the slides will come online, or on the TDOS, or on, I think TDOS will put them online also.
I think they will.
Yeah, okay.
They'll probably send you an email regarding this after the conference. So there's a social event starting, a social event this evening, and there might still be tickets for those who haven't signed up. So if you want to go, and the cost will be €30 for this. At the bar they might know more. And the other lectures will be going on for at least half an hour, so there will be at least half an hour before they start breaking up everything.